Hi everyone, welcome back to my channel Vertex MrRoy. Today we are doing revision exercise 1 from the additional maths book. Most of the students requested me to make the video for the revision exercises, especially the students of zero semester IBA-SUKKUR. And I'm very happy that you are watching my video and my videos are helping you. And this is especially for you because this exercises, revision exercises are very important for the examination point of view because we have chapter number 1 till 5 combined chapters so that we can have the variety of the question in these revision exercise. So let's start with question number 1. In question number 1, given that a is an odd positive integers, x is less than 5. Sorry, x is less than 7. So x is less than 7 means, and positive means it can be from 0 to 7, but odd means the A will be the first part we're doing question 1 part A, and that's 1. List the elements of set A and B. Okay, set A will be 1, 3, 5 and till 7 because it's equals to 7. And B is the prime number, and prime number means x plus 1 less than 39. We have like x is a prime number. Prime numbers are those numbers which are divided by itself for 1. So prime number list we can write 2, 3, 5, 7, not 8, not 9, 10, not 11, then 13. These are the prime numbers which are divisible by itself or which does not come in any other table. So we can test from 2. If I write 2 here, 2 plus 1 is coming, is 3 times 2 is 6, is less than 39. Yes, you're right. So we can write B, the first element is 2. Let's check 3. If I write 3 here, 3, 3 3 and 3 plus 1, it makes 4. 4 times 3 is 12. So 12 is less than 39. Yes, right. We can write 3 and then we can write 5 plus 5 into 5 plus 1 is 6 times 5 is 30. We can write 5. But when we write 7 here, 7 and 7 plus 1. So 7 plus 1 is 8. And when we multiply, this is coming 56. And that is wrong because 56 is more than 39, not less than. So I will not write 7. I will write till 2, 3 and 7. That's 2, 3 and 5 are the members of set B as we have done. Second part is find an integer. Remember, what is integer? Integer means is all never in decimal. Or integers always like numbers not in decimal. So please just keep in your mind. So x is a member of A but not the member of B. Okay, x is a member of A but not the member of B. First of all, we have to decide what are the common elements. 3, 5 are the common elements. Okay, it means 1, we are talking about elements of A. 1 is not in B, 7 is not in B, so we write that the first element is 1 or it can be 7. Because these two elements are in A but not in B. So the third part is find the integer. Once again, integer not in decimal, such that x is not the member of A. Not the member means x is not in A but is in B. So check it out. 3 and 5 we do not need to use. 2, so we can write only 2 because 2 is in B but not in 1 and like not in A. And I think so we have done the A part. Now moving to part B. In part B, simultaneous equation 2x plus y is equal to 3. And the second equation is the quadratic equation. And this is a part of chapter 2. Is simultaneous equations like little bit lengthy because we have a quadratic equation. So we can make y as a subject here. Subject means we always write y is equal to something and it should be always positive. So this I can substitute here. X squared plus 3 minus 2x whole square plus 4 3 minus 2x equal to 6, and we can use a perfect square formula here. A square minus 2ab plus b square is coming. I'm just writing for you, so you can a square minus 2ab plus b square. And then we can multiply this. 4 times 3 is 12 minus 8x is equal to 6. I used here a formula a minus b whole square is equal to a square minus 2ab plus b square. I know the IBA students are the medical students and they are not having the mathematics background, so they will have some problem to understand, and I know you require each and every part to be solved, but I'm trying my best to solve. So I think so now it's very simple. You can find the value of x. You will be having two values of x maybe because it's a quadratic equation. And when we have two values of x, you can substitute here. Then you can get the value of y. So we have done question number 1. Question number 2, we have question number 2 is about chapter 3 completely. And we can start now. First part, 32 power is 5x. And 8 power is 13 plus 4x. In this situation, when the bases are same, when the can you make the same as the base of something like power of 2? Power of 2 is very important. Power of 2 means the base should be 2. So 32, we can you can use a calculator, but this is the way. 2 times is 16, 2 times 8, 2 times 4, 2 times 2, and 2 times 1. 2. We can write 2 power 5 is equals to 32. And here you can see 2 power 3 is equals to 8. So this will become, I can write here 2 power 5 in the place of 32. I can write 2 power 5 in the bracket, and I can write this 2 power 3 in the bracket. You can only compare the powers when the bases are same. I can write 5x here and 13 plus 4x. Now, power to power, as a rule here, when we have a square power is 3, it means it will always multiply 6. But please, when you have 2 power 3, this will not multiply. It means this is 2 is 3 times. That's why it's coming 8. So by observing this, being a medical student, I am going to explain each and every step. Video can be a little bit lengthy, so sorry for that actually, but I want to explain everything. So this 2 power to power is multiplied is coming 2 power 25x, and this is we can write as a I want to write here 2 power 25x, and 2 power we can write power to power is multiplied is coming 39 plus 12x. Now base is the same, we can compare the powers. So 25x is equal to 39 plus 12x, and when we move 25x minus 12x is coming 13x, and 13x when we divide x with 39 divided by 13 is coming 3, and we have done it. So this is the way this we have done question number A of 2. Moving to second part now. In the second part, we can see the logarithm. For log, I think so. I have already done this chapter 3 with logarithm with all explanation. But when I'm doing this question with all the question, I will be explaining little bit about the topic. Y plus 1, sorry, is minus 1 is equals to 1 plus log 2 3y. Okay. This is log 2 base 2 log base 2. There's only one, and log base 2. One more thing very important, when we have here I want to make this log base 2. Remember, when you have log and you will not write anything here is a mistake. You have to write something here. This is not automatically 10. When you want to write 10 here, this will become LG. LG means this is log 10. But when you write log, you have to write something here. You cannot ignore this. Only log is not base 10. is a big mistake. But in calculator, log is base 10. Once again, in calculator, log is base 10. But in writing, when you write something, please don't write log only. Write something 2x 5. But when you want to write 10 here, it's very simple to write only lg, because lg means it's automatically base 10. Okay, now moving. I want to write here 1 as log base 2. So base 2 in base 2 is always equals to 1. For example, you have x and x is always equals to 1. You have log 3 is always equals to 1. So what you need, which base you need here? Log 2, log 2, log 2. So I will write in the place of 1. I will write in the place of 1. I am writing with a different color, so that is the second step. Log base 2 is equals to 1, and I have to copy the other part. So I have done the second step directly here. So this is very important. The first rule, like this, a rule is for when the bases and the number is same, this equals to 1. So that's why the LG10 is always equals to 1, because this is base 10, this is 10, so it's equals to 1. So now, when the bases are same in plus, so we can write, normally when you want to compare this, you have to write single log in both the sides. So log 2, because bases are same, and plus means we have to multiply y plus 6 into y minus 1 is equals to, like bases are same, and there is no coefficient with log, so I can write 2 multiplied by 3y. Now, by this way, we can, actually, we're not cancelling this. No, we are comparing the, only this part, only this part. So now, what we have now? We have y plus 6 and y minus 1 is equals to 6y. Okay, y squared, then we have minus y plus 6y and minus 6y, we can shift in left hand side equal to 0. This is cancel out, and we have only y squared minus y minus 6 equal to 0, and the factors are minus to get 1 and 3 and 2. We can write 3y plus 2y, so y is common, 2 is common. So finally we have y minus 3 and then y plus 2 equals to 0. One more step, very important step here, because when you know the value of y is coming 3 and y is coming minus 2, we have to check one thing here. Please, this is very important to check. What check? Log 2, log 2, log 2, and 3y. This is good. When you write 3 here, 3 times 3 is 9. Is this area is coming positive. But when you substitute here minus 2, the minus 2, like 3 into minus 2 is coming minus 6. And please, log cannot be like this. Log with base 2, it cannot be negative. Never negative. If this is negative, it means this is not possible. So I will ignore this part. Ignore. And the right answer is only y equals to 3. And I think so I should check the answer of question number 2. Question number 2, the 3 and the B is coming also 3. Okay, 3 and 3, and we have done it. So yes, we have done it. Next is quite like C part. For C part, I would like to do, because the C part is very important. Like C part, why is important? Because in A part we can make like the base of 2 as we have done. In C part, we cannot make for x plus 2 and 27. I cannot make this as a base of power of 4, or I cannot make this power of like 3. 27 is 3 power. I cannot make it. So this situation is very important. Now, what I'm going to do is very important. When in right hand side and the left hand side, both the sides, when we cannot make the same basis like in question number A, we can make the same basis like base like 2. When you cannot make the same basis, what you have to do, you have to apply LG both the sides. LG here and LG here, because LG means base 10. Even you can apply ln. ln means log base e. There is no problem if you apply here ln. Your answer will be definitely right. There is no problem. You can use it. But when already e is not in this question, so I will write only lg. Okay. This I use the power here. So law something. So what's the power law here? X plus 2 will become the coefficient. X plus 2, and we can write lg 4 equals to this 27 is normally just 27. So I'm writing lg 27. And I have to use here lg 27 divided by lg 4. This is x plus 2. And I have to use the calculator. So x plus 2, what we can do here now, how we can like write this in your calculator. Please, in your calculator, the lg is log. In calculator, what you have to write, like you write log in the bracket 27 divided by log in the bracket 4 and bracket close. This is in calculator to write. When you substitute this, your answer will be coming 2.377 x plus 2. And when you shift this to the right hand side is minus 2, it will become 0.377. And we have done question number 2. Question number 3. We have about once again the logarithm. This is chapter 3, pure chapter 3, and let's start. 3 part A. If u is equals to log 4x, and show that, okay, we have to show that. I have to apply the property of log here. Let's see. This is I made one thing, a new formula for change of base law. What is change of base law? We have two possibilities here. Change of base law. Okay, the first thing. The first possibility is like we can say like interchange of base. Interchange of base means when you have, suppose, when you have this log, and this is x and this is a. Interchange of base means when you want to make a as a base, what will happen? 1 upon log ax. This is interchange of base. 1 upon something. For example, you have log x2, and 2 will become like base and x, and this is 1. This is interchange of base. Second, in change of base law, we have like the third base. We need the third base. Third base means when you do not require a or x as a base. When you want the third base, suppose we need the base of y or base of 3. So let's see what will happen now. Log x a is equals to, I will write log, please don't write lg, please. I will write 3 here as a base, 3 here as a base, because it's the third base, new base. And ax will become a upon x. Very simple. For example, I want to give here an example. I want to make the base of 10. The base of 10 is lg, lg, lg 2 upon x. Even I can write log base of y, log base of y 2 upon x. Like this is very simple. So with this question, which each and every question I'll be going to discuss and explain the terms, that's what, how we have to apply the formula and everything. Okay. Now, if we want to show that this one, I have to copy this first of all, the question log or x. Okay. I have this formula interchange because in right hand side, when you want to show something here, the base is x and this is base 4. In the given question, the base is 4 and the required question is base x. So it means you want to make base x means interchange. So when you will interchange this, I will write 1 upon log x will become the base and 4 will come here. And this is u. Now I have applied the like interchange of base. Now what you can do, you can write cross multiplication. You can move this here to left hand side. and you will divide. So I think so we have shown. This is 10. This is the first part. Okay, hence find the value of x for which this, okay, 2 log 4. We just need to substitute the value now. This type of question we have like frequent question in O levels, admits, in past papers, in exams. So 2 log 4x is here is u plus 3 log x4 is 1 upon u. And I think so we have here a quadratic equation when you take the LCM. For the LCM is u, we have a method actually I want to discuss with you. When you have the LCM of any of the equation, multiply by the LCM. What's the LCM? LCM is u. Okay, u times 2 is 2u squared. U, 3 upon u multiplied by u cancel is only 3. And this is coming 7u. This is the easiest way to remove the denominator like from the equation. So 2u squared minus 7u and plus 3 is equal to 0. Okay, 2 times 3 is 6. Multiply to get 6 and plus to get 7. I have made a video like breaking the middle term like last about 2 days before I have this uploaded a video. So you can check. Breaking the middle term. Now, multiply to get 6 and plus to get 7 means the factors are 6 and 1. Because when we plus is coming 7, so 2u squared plus like minus 6u and minus u and plus 3. There is a way that why I'm solving the whole question because we have to do one thing at the end. So be careful. 2u is common, u minus 3. Nothing is common, 1u minus 3 equal to 0. So u minus 3 is one factor and 2u minus 1 is other factor equal to 0. Now we have to apply a very important thing here because this is not sometimes in the exam students write the answer till here and that's it. What this here I just want to tell you they write like this: u minus 3 equal to 0 and u is 3 and we have done it. No, this is wrong. We have not done it. We have to do one more thing here. 2u minus 1 equal to 0, u is equals to 1 upon 2. Okay, now we have to apply here since. What since? Because we have to find x, not u, not u. We have to find x. So I have to apply since means u is equal to log 4x. So in the place of u, I will write 3 is equals to log 4x. And here I will write 1 upon 2 is equals to log 4x. Now, once again, we have to apply here like index form and the log form. When you have like in log form is log a b is equal to c will become a power c is equals to b. This is index form. So I would like base will remain base. A is base. A will remain base. Power c is equals to b. So what I will write? This 4 will remain 4, like base power 3 is equals to x. And x is coming, 4 times 3 is, I think so, 48, 16, is coming, oh, sorry, 64. Sometimes my mind is stuck. So 4 power 1 upon 2 is equals to x and x is coming only 2 and we have done perfectly. There is no problem, I think so. So second part, we are moving to part B now. In part B, we have to be careful now. Okay. In B part, we have given that log 3x equals to a, log 3y. Okay, this is most important part. And I would like to say one thing, as a power of 3 means 3 should not be here. This is wrong. 3 should be at the base, power something. As a power of 3 means 3 should be here. 3 should be base and power can be anything. So let's see. Log These are the given, like log 3, the value of a and b are given, and we have to write x squared y. So I just need to put the value. X is, okay, first of all, we have to find the value of x, like subject. Log 3x equals to a. So, index form, what is the index form? 3 will remain 3, base, and power a is equals to x. So, x is equals to 3 power a. We have done first part. We know the value of a, we know the value of x, and by the same way, we can have the value of y. Log under root 3 y is equals to b. So, under root 3 power b is equals to y. So we have the value of y now. Y is equals to under root 3 means power is 1 upon 2. So 3 power 1 upon 2 multiplied by b is b upon 2. I will write b upon 2. Okay. We know the value of y also. So x squared y will be equal to x squared is this. So I write 3a whole square multiplied by y is this one, 3 power b like this. And bases are same. When the bases are same, power is like 2a plus b upon 2, or you can take the LCM, or it's up to you. I think so it's okay. We don't need to simplify further. Second is x upon y squared. What is x? X is 3 power a and y is 3 power b upon 2, the whole power is squared. This 2 to cancel out is only 3 power a upon 3 power b now. When you have the same basis, power will move up. So this will become a minus b. This one and this one. Let me check the answer of this part. Question number 3. Question number 3, 2 and 64. We did 2 and 64. Yes, we have done it. And this is 2a plus half b, and this a plus this right. Next part is sometimes the mistakes are possible because I'm doing sometime without calculator, sometimes in hurry. So please don't mind when I have some like mistake. You can do yourself. Just please, thank you. So hence x squared y is equals to 1. When x squared y is equals to 1, and x squared y, we got the value of x squared y equals to this. We can write 3 2a plus b upon 2 is equals to 1. This is first condition. And this is most important part here because I want same basis. So same basis means, let's see, let me do the second part. And x upon y squared is equals to 1 upon 243. And x upon y square is here. I can write here 3a minus b is equals to 1 upon 243. 243, I can make the base of like, I can make the power of 3 we have done. So, okay, let's see. 243, you can make the, I think so, 243 should be sometimes 1 and 2, 3, 4, 5. Yes, 3 power 5 is 243. So this is 3 power 5. This is, we can write 3 power 5. And this 3 power 5, when I move up, this will become 3 power minus 5. And a minus b, because bases are same, we can write a minus b is equals to minus 5. This is the first equation. Now I'm moving to this part. This is 3. I want to make this 1 as 3. So it's very simple. Anything having 0 power is equals to 1. When you have 5 here, you can write 5 power 0. When you have 6 here, you can write 6 power 0. When you have x here, you can write x power 0. So when we have 3, so 3 power 0, and this is the same. So we can write 2a plus b upon 2 is equals to 0. This is equation number 2. Now equation 1 and equation 2, you can do it like simultaneous equation to find the value of A and B. So once again, today I'm just doing question number 1 till 3. The video is going to lengthy. Next video, I'll be continuing with the question number 4 onward. So once again, thank you so much, and especially the zero semester students, wish you all the best for the exam. Thank you so much and have a nice day.